This is the first video for the chapter lenses, and it's a chapter that you've done before, I know, in class 8. And actually it's just an application of the previous chapter in your class 10 syllabus, that's refraction. So instead of having just plain mirrors and plain glass slabs, you're going to go into curved surfaces, which are called lenses. And lenses are actually, it's a part of a spherical mirror. So it's as if from a spherical mirror you cut a part of it. We'll come to that later, you'll see how it is. But just to start off, the basics: convex, concave, I'm sure you all know it. This is convex, which is bulging out at the centers and is thin at the edges. Thicker at the center, thinner at the edges. You can see over here. Concave is the opposite. The way to remember it is that the cave goes in. So you can see that the concave goes in at the center. But this is something you'll get very used to it. There'll be no need to memorize it as such. Right? You'll be doing a lot of this, so it's thicker at the edges, thinner at the center. Now, these are it's not correct to call them just convex and concave lenses. The real term for these specifically would be biconvex and biconcave. They do come under the general category of convex and concave respectively, but the correct term for these two would be biconvex, biconcave. Bi over here means dual on both sides. So you can see that not only is this, I'll change color here, not only is this convex here, but it's also convex here. Same way there's concave here, there's concave here. Now, same way you have plano-convex and plano-concave. Plano-convex looks something like this. Okay, plano-concave looks like this. It's just splitting these two into half and taking the one on the left. That's how you can remember it. Also, another way to remember it is that in these two lenses, and there are going to be two more that I tell you about, the term that is mentioned first, like it's plano-convex. Plano, then is convex, or plano, then concave. The one that we mentioned first over here is plano, comes on the right side. So you can see here that the plane surface is on the right side, while the convex or concave surfaces are both on the left. Same way, you have concavo-convex and convexo-concave. There's a difference between them, and as I said, the one which comes first comes on the right side. So you can see that convexo-concave, convex would be on the right hand side, so it would look something like this. This is convexo, concave. Concave is here on the left. Convexo, since it comes first, is on the right. And same way you have the opposite, which is concavo, convex, and concave is on the right, convex is on the left. Looks something like this is not a very good representation of it, but I think you know what I'm trying to say. So concave here comes on the right hand side, since it's concavo, convex, and the convex will come on the left. So that's the best way to remember it, but you're not really asked much of this. It's just something that you should know. Another important thing, convex is known as the converging lens. Why is that? That's because any rays that are incident on them, they all converge when they pass through it. We'll do much more of that later. We'll be doing many examples as well. Concave, meanwhile, is called the diverging lens. If you want an easy way to remember it, just look at convex. Just ignore the x at the end, look at convex, and here you have converge, convex again. And concave will obviously be the other one then. But again, same as what I said here, you'll be doing examples of this. That's what your whole chapter is about, so no need to remember these, it'll come automatically to you. Another thing, I should clear this out before I move on. So you have more terms that are associated with lenses. I'm sure you've done them before whenever you did the chapter, I think 2 years ago, but I'm still going to go over them. They're not really tested or anything as such, but it's good to know them because I'm going to be referring to them a lot when I'm going through the examples. So say you have, let's take a convex for now, it's a more common one. Another thing, convex can actually be represented like this, but only in your diagrams, that is. This makes it simpler to draw your diagrams. There's just a straight line instead of the whole curve over here. But right now I'm going to just use this one here. So, and similarly, your concave is the opposite. Your arrows are pointing in the opposite way. You can see why it is so. This resembles sort of a convex, while this kind of represents a concave. I'll come to this again when I draw my diagrams. But here, I should draw this again now. I'm pretty sure you all have come across the term principal axis, optical center. So, as I told you at the beginning, all these lenses are just parts of spherical mirrors. So, you can imagine that this convex lens here was part of two spheres. I'll take a different color for this. There would have been two spherical mirrors like this. Cool. Something like this, and this was cut out of this. You can see that the two surfaces, I'm going to remove these circles now. You can see that the two convex surfaces are both curved like a sphere. So when you have these two surfaces, they both correspond to a certain sphere. They both will be different spheres. They might have the same radius or they might not. For example, you can have something like this, and then something which is not curved very much. So you can see that for the right hand surface, the radius will be much more because there's not much of a curve. I don't have space because I'm going to go into the heading otherwise, but I think you can see my point here. Well, if you look at the left surface, you can see that if you try and form a circle from it, it's going to look something like this. So clearly the radius of the less curved surfaces is more than that of the more curved surfaces. So we take two spherical mirrors, and carve this lens out of that. So now each of these spheres has a certain center of the two spheres. So say there's one here and there's one here. These are called the centers of curvature. I'm sure you've done all this before, but again, I'm just going through this very quickly now. And there's a line, the straight line that joins these two, like this. This is called your principal axis. So say this is sphere 1, this is sphere 2 over here, two centers, straight line joining it. And you also have something called the optical center. So optical center will lie on the principal axis somewhere over here. We can't really tell the exact position right now, but it should be somewhere here in the center. But the optical center, you can define it as the point on the principal axis, that's for sure, it'll always be on the principal axis, such that any ray that passes through it will emerge parallel to its original direction. So the emergent ray is parallel to the incident ray. So you can see, for example, if a ray comes in like this, if this is indeed the optical center, should go roughly like this. I say roughly and not exactly. I'll come to that reason as well later. But that's all you need to know right now in this tutorial. This is just a small introduction. Again, if you have a ray like this, you have a ray like this, they'll all just go straight through it. And same will be true for a concave as well. That's not very nice. But say this is the optical center here. You pass a ray like this, it'll go straight through. Even though these two are diverging, converging lenses, they will not get diverged or converged if they go through the optical center, that is. So that's it for this one. I'm out of time here, so I'm going to continue this in the next with a few more terms like focal length, first principle focus, second principle focus, and also I'm going to tell you how you can actually split these lenses and form prisms and glass slabs, which is how you understand convergence and divergence. But all that's in the next tutorial.